Hello and what's up to you all pre-matriculants? Welcome to it. This is Learn Extra Live and you love this show and I love this show. I'm ready to learn more and learn extra with you guys. My name is Abram and I'm with John today. John, how's it?
Doing well, thanks, Abram, and welcome, grade 11s. We're here for you. I know that some of you are feeling a little bit left out because you weren't part of spring school. Thank you to those of you that did tune in and maybe you learned some things. But guys, we've got some news. Some of you can join us not only in this time slot, but a little later. There'll be more news on it. We've got exam revision coming up for you as well. So don't feel left out. We're here for you as well, all the way to the end of November. So we've got your back. We want to make sure that you get the best marks you can too as well.
Awesome. And all you need to do is to get connected with us and you'll never be left behind. What are we doing today?
Okay, so because we're straight back to school, and there is a little bit of teaching that still needs to take place for the grade 11s. We're going to focus on a very important principle that will carry through to grade 12, and it's called Redox Reactions. Okay, now you might say Redox, no, is this an art class? Hey? Is this a design class? Have you ever seen a Redox?
Yes, I have.
Yeah, one of those.
I'm wondering what does that have to do?
What has that got to do with chemistry? So it's not about making little clay models or computer animations that have little oxen running across the field, or something that you might find outside in Kandla, those red oxen in the field, in that R1 million crawl. We won't go there. But this is about some real chemistry. But you need to first of all make sure you get the notes, check the page out. There's a challenge question waiting for you. AB, how can they get those things?
Of course, John. You go to Learn Extra, which is facebook.com/Learn Extra. It is XTRA. That is our extra without an E. Also on Twitter, follow us at Learn Extra. Still XTRA. That is the extra on Learn Extra. We've got awesome giveaway for you guys because we love you guys so much. If you think you are a bright spark and you shine bright like a mindsetter, all you need to do is to get yourself this K53 Safeways official driver's and manual book and also an app. If you have the book, then get the app because, you know, those are two different things and the app is cool as well as the book. So if you have the book, now get the app. If you have the app, then get the book because they go hand in hand. We're helping you guys to get your learners and also drivers because it's very much important. At this time and age, you must have your own driver's license and learners. You stand a chance of winning a car.
Hey, that's amazing. But guys, just not only if you're trying to learn to drive. You know what? I'm shocked about the number of road accidents over the holiday season where there are pedestrians involved. And it's because people haven't committed to their ideas, don't know what the rules of the road are. And it's really sad because every person is precious. Every person has value. And it's just such a tragedy that so many people die over the festive season. So make sure you get that app, get the book. You'll enter a competition. You've got a chance to win a car. But also stay tuned because there's going to be a little bit of an instruction just now between the grade 11 and the grade 12 show where we're going to show you how to do a three-point turn. Isn't that right?
It is, John. And it's cool. I must say that the videos, you learn more on videos than learning more on a book. So it is a cool way of mindset helping us as well. I'm learning so much as well because I just got my license, so I'm new.
Okay. Now, guys, if you're new as well, AB's going to post something else on the page. If you want to test, you're going for the learner's license, you want to test to see whether you've got all the answers right and you're ready to go, well, there's a little thing that he's going to post on the page, a little questionnaire that I've drawn up, a quiz for you. You're going to have to get onto Curio, register on Curio as a free account, doesn't cost you anything, but it gives you the advantage of entering all our competitions, entering all our quizzes, and you get immediate feedback. So there are two Curio quizzes for this show. One is on the K53, and it's got some amazing answers, and I'm sure you'll be rolling in the aisles when you go in and look at those. Very important issue that we're raising with those signs and checking to see whether you know it. And the second one is all about redox reactions and redox equations. Shall we get straight into it then? And let me not do any more chatting about competitions and what have you. So what we're going to learn today is, first of all, obviously decide what redox is, and then learn how to assign oxidation numbers. We're going to write half reactions to show reduction and oxidation half reactions. We're going to combine those to make net-ionic reactions. Now, I hope we can get through all of that. I'm sure we can, because you know what, AB, this is one of my favorite sections. And before I carry on, I want to just give the challenge question, which is posted on the page. And you see, we want to bring it back and make it relevant because we're talking about cars. So I know you just recently started to drive. Have you ever thought about what the chemical reactions there are in cars? Come on.
Of course, I mean, there's water, there's petrol as well, so there must be.
There's a chemical reaction. The water and the petrol don't combine, by the way.
Yes.
You don't put water in that tank at the end. It won't make your car go, okay?
Yeah.
The water is there as a coolant. That's the only thing the water does. Cools the engine. You don't want to get too hot. The petrol, however, is an organic compound, and it reacts with oxygen in the air to produce carbon dioxide and some water, which comes out of the exhaust. So that's one reaction. There is another reaction that I want you to think about in the car, and it happens over a longer period of time. I want you to think about those reactions and see if you can not only identify the reactions taking place, but identify which reactions are redox reactions. And can you identify the reducing agent and oxidizing agent in these reactions that you select? So guys, there's a challenge for you. You're going to need to listen carefully to the summary to make sense of this, this particular challenge question. So let's get straight into it. AB, one of the ways that I love to learn is to make up stories that stick in my head. Okay?
I like drawing.
So make sketches, make drawings, and there's a special name for it when you're learning how to learn. It talks about making something called a mnemonic. I'm not even going to try and spell that. But a mnemonic is a little phrase or little word that represents other sentences. So if you learn one little thing, then in fact it unlocks the key to a whole lot of other information. So I'm going to write a word on the board here, and I'm going to write a word like this. And I'm going to write a second word underneath it that goes like this. Okay. So, AB, have you heard, if we read that, it says oil rig.
Yes.
What is an oil rig? Any ideas? Come, AB, idea. What is an oil rig?
Let me think about it.
Come, no, there's no time to think about it. If you go out into the sea, there's these drilling platforms that will have the sea underneath, and they put down into the sea these shafts that go and drill for oil. This floating platform, which is they're huge. They're like, I've just drawn it, sketched it like this. But they float around. They're like big office buildings on stilts, floating around in the sea. And they explore for oil that's in the sea. You get them in the overseas in the Gulf of Mexico. There was one a couple of years ago where the seal right down at the bottom over here started to leak oil, and it created a hazard for the environment. You get them in the North Sea, and there's sometimes fires on these oil rigs, and people get paid a huge amount of money to go and work on one of these oil rigs. In fact, it's a most amazing job because you get out there, you work hard, you're there for a couple of weeks, you come back, and you're off for the same amount of time as you were on the oil rig. You get big bucks, and but you have to really work hard. It's not really good for family life, but for a young person wanting to get skills about whether it's medical skills, whether it's engineering skills, whether it's just operating skills, it's really a good option. So look out for working on an oil rig. Dangerous work, but amazing stuff. So there's a picture of an oil rig, okay? So what's an oil rig got to do with chemistry? Other than that oil is a chemical compound that's very important. Well, you see, hopefully you'll get this picture. And perhaps you'd like to Google it. You'd like to Google it and post a picture of an oil rig on the page for the learners. Will you do that?
I've done that already.
You've done it already?
Yes.
Hey, you see, great minds, eh? We're just on the same wavelength. So what does this thing stand for? You get the picture of oil rig in your mind. Now, what I want you to remember is that oil rig stands for something. The O stands for the word oxidation. So there we go. The I stands for the little word is, and the L stands for the word loss. So what does oil stand for? Oxidation is loss. A loss of what? A loss of electrons. So we've just got to remember that bit. But oil is oxidation is a loss of electrons. Now, what about rig? Well, I hope you've got it. You're following me. We're going to say that reduction is a gain of electrons. Now, if you can remember that, then you're away. You're really, those are the basic definitions. So what are we going to say about this word redox? Well, look here. If we've got oxidation and reduction, we just simply take red from the reduction, and we take ox, and we add those two together, and we get red ox. How cool is that? Okay? So a redox reaction is one in which there is a loss of electrons from one reactant and a gain of electrons by another reactant. So when we put two things together in a chemical reaction, remember the starting things are called the reactants, and when one reactant loses electrons, the other reactant gains the electrons, and then we've got products, different things. When you've lost an electron, you've changed. When you gain an electron, you've changed. And so we've got products that are formed because there has been a transfer of electrons. And so a redox reaction, yes, is made up of oxidation and reduction half reactions, but it is simply a reaction in which there is a transfer of electrons. A transfer of electrons. Okay, guys? Hope you got that very clear. Now, the next thing that I need to do, and this is amazing. I need AB to come and join me here. Can you do that? Yeah?
Yes.
Okay, okay, so AB, he's in the same room as me, and we want to just act out. AB's looking really cool. Haven't you got some sunglasses? The haircut's looking good.
Thank you.
I mean, it could improve a little bit, but I mean, it's not as good as mine, but we'll get there.
No, I'll do the one like yours.
You've been promising
You're my
that.
role model.
You've been promising that for ages. When you're an old man, maybe you can.
No, sir.
Okay, so because he's so cool, okay, I want you to understand that in chemistry, we have different agents. So you've got that story, and I hope it's gone into your mind, oil rig. Do you think they'll remember?
Yes, they
They
will.
should.
Yeah.
You must remember, oil rig, oxidation is loss, reduction is gain. Now, remember this, AB's the cool dude. Okay, he's got such a cool instrument. It's like the sonic pen. You know the sonic screwdriver?
Yes, yes.
There's a television series that you might want to watch on another channel, but it's all about a doctor, and I'm not sure who he is, but anyway, you just need to have a look at that. AB's got this special pen. It guarantees him, we're going to act out something here. AB is a cool agent. He's so cool, we're going to call him Rad. Is that a cool? That's
cool.
fine.
It's
You
rad.
like to be
It's
called
rad.
Rad, hey?
Yeah.
So remember, AB's Rad. Okay, I need to write that on the board. So let's just change our tactic, and we're going to write the word rad. Okay, and you must please remember this. Okay, so in chemistry we have these chemical agents. Some are rad, and some of them are not rad. And we couldn't find another word for them. So we'll find a set of letters for them. I'm going to call them OAT. O-A-T. So it's a bit like eating your breakfast. You're going to eat porridge. Rad eats porridge for breakfast. Oat, rad, oat. Doesn't matter which way you learn it. But rad and oat are the two chemical agents, the secret agents, double O chemistry. Okay? And so AB here has got this amazing sonic pen. Okay, it's going to represent electrons. Okay, it's an electron pen because he's a rad agent. Okay, chemical agent that is rad. What is he going to do to those electrons? You see, because he's so rad and he's such a good guy, if he sees somebody that's poor and suffering, that's just a little oat, hasn't got much going for it, What's the rad fella going to do? The rad fella is going to donate, thank you, going to donate those electron pens. And then it's like a jack of the beanstalk. He can plant the magic pen and he can get all sorts of things. Okay. So what I want you to see is there's been a transfer. Let's do it again. So what did AB do? He's the rad guy. Remember? He donated to the oat. What did the oat have to do? Had to take it. Right. AB, thank you. You got it?
Yes, I got it.
Rad donates. Oat takes. Now let's unpack it. So, guys, as I said, they're these chemical agents. They travel around in solutions, in fast cars, waiting, not sure what to do. No, in solutions or in gases, wherever there's chemistry taking place, there are rad things happening because chemistry is so cool. And this is the last point for today. So what I want you to understand is rad stands for reducing agent. And what does a reducing agent do? It donates because it's rad to care for others. It's cool to give away. Okay? More, if you've got a little bit of extra, share it. Oat, oxidizing agent. What does it do? It takes. Now, you see, we can't all be donators. We can't all be donors. Somebody's got to take. And so if you are in a weaker position, then be generous and accept the gifts that people give to you. And in chemistry, it's exactly the same. If there are rads around, reducing agents, they're going to donate. But look what happens when they donate. If this thing donates, it has lost electrons. So a reducing agent will always undergo oxidation. In its process of donation, it's making the other thing gain electrons. So an oxidizing agent will always undergo, an oxidizing agent takes electrons, it will always undergo reduction. Because the reducing agent has made it to undergo reduction. The oxidizing agent has made the other reactant undergo oxidation. So hope you've got those two. Make sure you think about it, and we're going to go to a short ad break. Thanks,
Thank you
AB.
so much, John. That is quite a rad concept, I must say. I'm learning so much. I hope you guys are also learning. Feel free to give us your questions if you're struggling, because we're here to donate to you guys. All you need to do it is to oat and take whatever we're giving you guys, but not everything, but we also expect some things from you guys. So we'll see you after the break. Welcome back, Mindsetters. If you just joined us now, well, you're a bit late, but I'm sure you can still catch up. Get your notes right now. We have the links on our Facebook page, which is facebook.com/LearnExtra. Also follow us on Twitter and send us your questions and your comment. We'd like to find out what you guys are on about. If you enjoyed also your day at school, what were you doing on your chemistry class? We'd like to find out. But remember, we've got awesome giveaways for you guys, and John is here to help me with that.
Okay, guys, please don't forget. There is a Curio question, a test yourself question. If you take a look at the notes, get the notes downloaded, and then go to Curio, q.na, and whether you've got a feature phone, if you use Opera Mini, look for q.na. If you've got a normal, if you've got a smartphone, if you've got a tablet, or if you've got a computer, q.na. Create yourself a free account. Get into that account, wait for the verification, then use the code. The code for this quiz, I've given it to AB. It's on the page. Enter that as the Curio. You'll get a chance to ask there are 5 questions. The response, once you submit, will be immediate, so you'll know how you've done. But by doing that, you'll be entered into the Casio competition. You'll get a chance to win a Casio calculator. So make sure you do that. There's also Get Connected competition. The Get Connected competition, vote for your favorite teacher. There are a whole list of them. We've done this before in the end of the 3rd term. We've isolated the 2 best the most popular teachers, not the best teachers, 2 most popular teachers that you voted for, okay? And they are in the list of 6. Get voting. Enter again via Curio. The code to use for that entry is LEARN, L-E-A-R-N. Make sure you enter it. Vote for your teacher that you like the best, and then get people to like the page. What can you win? AB, what can they win?
Well, for the Get Connected commission, you could win an airtime, probably sponsored by Vodacom, or the Sony Xperia L cell phone. It's very cool, guys, so you do want to get connected.
And we started with 4, and there's only 1 left.
Yes.
So guys, this is your chance. Today is the day you need to enter. And then the last competition, which we'll say a little bit more about a little later, is the K53. Make sure that you get the book and that you get the app to enter that competition. You get extra points for liking and sharing the pages. So make sure you do that. We'll be talking more about that in a little while. Can I get on and do my chemistry now?
Yes, please.
Okay, thank you. Now that I've done half of your job. Okay, guys, first question. Make sure you get the notes. A full explanation on the other concepts about what is oxidation, what is reduction, what is an oxidizing agent. It's all in the notes. I summarized it for you. There's also a list of rules to apply to help you determine whether something is a redox reaction or not. We call this the assigning of oxidation numbers. So the first question is for us to find the oxidation number of sulfur in the following compounds. Now, I'm going to go through it, and I'm going to refer to the rules. So you need to know these rules, and they're really quite straightforward, and I'll break them down for you. So quickly, let me just go over the rules because I was talking too much previously. Here are the 9 rules for us for assigning oxidation numbers. The oxidation number of any free element is always 0. So that's easy. If we've got something like He or Mg, it's 0. Okay, the unit oxidation number. The oxidation number of a monatomic ion equals the charge on the ion. So Cl minus, we would say the oxidation number on this is -1. The usual oxidation number of hydrogen is +1, and the usual oxidation number of oxygen is -2. And really, those rules will help you assign all the oxidation numbers that you need to. There are a couple more, because oxidation numbers are a bit like valency. And so what we're saying, group 1, group 2, group 17, they take on the oxidation numbers +1, +2, and -1 respectively. Then the next thing that's really important, the sum of the oxidation numbers of all the atoms in a neutral compound is 0. So we have something, if we have something like NaCl, then this one would be +1, that one would be -1, and we could put down the total oxidation number, here is +1, -1, and we add those two together and we say that those added together is 0. Okay, and then the last thing is the oxidation numbers in a polyatomic ion, something like SO42 minus. What's that going to add up to? Total oxidation numbers -2. Okay, very quick revision. We're going to do some more practice of applying these rules. So let's go to the first one, and we say the first one is sodium sulfide. Now, sodium sulfide has a formula of Na2S. What did we say about the unit oxidation number of sodium? Well, it is +1. But there are 2 sodiums here, so I've written the oxidation number at the bottom. I'm going to multiply this, sorry, let's do it this way. I'm going to write it at the top. I'm going to multiply that by 2. That's the unit oxidation number. I'm going to multiply it by 2 to give me the total at the bottom. Use a different colored pen. +2 over here. Now, what do I know about sulfur? Sulfur can have many oxidation numbers. That's why all of these elements, or these compound species that I've put down here, have different oxidation numbers. We're showing you how to do them. What do we know? How are we going to get it? Well, we know that the total of whatever is here has to add up to zeros. So +2. And what must I do to +2 to give me 0? I must surely add in minus 2. Now, we're working backwards. What's the unit oxidation number of sulfur? Well, there's only one sulfur there. So if there's one sulfur and the total was minus 2, 1 times minus 2 is minus 2. So the oxidation number of sulfur, of the sulfur ion in sodium sulfide, is minus 2. Can we check that? Yes, of course we can. We can say we have an ion that is called sulfide from the name. And we recognize sulfide is 2 minus as the charge on it. So the oxidation number is minus 2. Okay. And so there we've got it. Let's go to the next one, sodium sulfate. And we're going to go down here, sodium sulfate, Na2SO4. And I'm watching my time because I don't want to run out of too much time. So guys, here I need to recognize and remember the sulfate ion is a polyatomic ion and it adds up to minus 2. We've done the sodium already, so we know that this total here is minus 2. So it doesn't surprise us from what we've done previously that that total must be plus 2 because that's plus 1. 2 times 1 is plus 2. That's how we get it. But now, how are we going to deal with this? Well, we come to that special rule that says oxygen is usually minus 2. And we're going to work with that. So we're going to oxygen minus 2. Minus 2 times 4 is minus 8. What must I add to minus 8 to get minus 2? Well, if I add plus 8, I'll get 0. But if I add plus 6, I'll get minus 2. So this one must be plus 6. This total at the bottom is plus 6. But how many sulfurs are there? Well, there's only one. So that means that the unit oxidation number of sulfur in this species is plus 6. And that's absolutely correct. Okay, I'm going to move on to the next one. And we're going to get, this one is a little unusual. Sodium thiosulfate. Let's try and work this one out. Sodium thiosulfate, Na2S2O3. Now, again, because we've been dealing with these, even if we didn't know it, the sodium is plus 2. That means this whole thing must be minus 2. Because we know that sodium is plus 1, it's in group 1, and we're not worried about that. Oxygen, we know, is minus 2, times 3 is minus 6. So then we must get what plus minus 6 is going to give us minus 2. That must be plus 4. Agree? Right. Now, can I just put a plus 4 at the top? No, because there are 2 of these sulfurs there. So plus 4 divided by 2 is going to give me my answer, which is plus 2. So sulfur in this case has an oxidation number of plus 2. Hope you can see that sulfur has variable valency. It has variable oxidation numbers. The oxidation numbers tell us how electron-rich or electron-poor a substance is. If it has got a high positive number, it's lost electrons. It's electron-poor. Big negative, a small negative number, in other words, a large value but negative, then it is electron rich. It's gained electrons. So if it's gained electrons, it has undergone reduction to gain electrons. It has the ability to donate electrons to something else that has got less electrons if it were reacting with that substance. So things that have large negative numbers are usually good reducing agents. What about S8? This is the normal form of sulfur, elemental sulfur. Remember, I'm not going to take too much time on this, that elemental sulfur, it's an element in its own, and we're going to say that it has an oxidation number of 0. So what about SO2? This one is very easy, so we're going to do it very quickly. We're going to say SO2, go through it one last time, applying the rules. Make sure you've got it. What do we know? We don't know sulfur. What do we know about oxygen? Help me. Minus 2. Minus 2 times 2. Come on, guys. What's that? Minus 2 times 2? Minus 4. What do we know about the total? In any molecule, it has to add up to 0. In any ion, it has to add up to the charge. We have a molecule here, sulfur dioxide. It's neutral. So this one must be plus 4. How many sulfurs are there? There's only one sulfur there. We don't even put the 1 there, but it is there as a 1. We indicated it. So the oxidation number of sulfur must be +4. +4 times 1 +4, and that all adds up to 0. So in my answer, I'm going to say the sulfur has an oxidation number of +4. Question 1, dusted and over. So next question. Hey guys, this is a bit more challenging, but it's a really interesting question. It tells us, it says use oxidation numbers to identify which, if any, redox reactions take place in each of the following industrial processes in which sulfuric acid is made. So we got sulfur plus oxygen gives us sulfur dioxide. We've got sulfur dioxide plus oxygen give us sulfur trioxide. Sulfur trioxide plus sulfuric acid to give us oleum, or fuming sulfuric acid. Okay, let's go through it. Very quickly, we have to decide, has there been a transfer of electrons? The way that I'm going to do it, I'm going to look at sulfur. Because we've just recently done sulfur, some of these we already know. So I'm going to start by this one, and I'm saying sulfur is 0 over there, and sulfur is +4 over there. As soon as I see there's been a change in oxidation number of one element, I know that it's a redox reaction. I've just got to find out what other element has changed. And in some cases, it could be the same element has changed in 2 ways. So let's go to oxygen. Oxygen is 0 there because it's O2. But what do we know about oxygen here? It's -2. So we have a change. We know that A is definitely a redox reaction. What about the next one? We know that this is +4. The sulfur is +4 over here. Now let's look at sulfur trioxide, and I hope you can see very quickly, -2 times 3 is -6, so that must be +6, so that must be +6. So the oxidation number of sulfur in the sulfur trioxide is +6. There's been a change. Notice as well, oxygen went from 0 to -2. So we know that that's also a redox reaction. Let's do the last one, and let's just make sure that we've got it right. SO3 plus sulfuric acid, H2SO4, gives us, I'm not balancing the equation, not interested in that, H2S2O7. And we've already done this one, +6. We know that's -2. This one is a sulfate, which we did earlier. That was +6 as well, because if we check it, -2 times 4 is -8. -8 plus 6 gives us -2. Hydrogen is +1, and there were +2 of those. Add those up, and you'll get 0. And so we know we're okay. So let's do this one. +1 plus 2 -2 times 7 -14. So now, what must I add to -14 plus 2 to give me 0? So if I take +2 -14, that's -12. So I must put a +12 over here. +12 divided by 2 is +6. Guys, have a look. What's happened to sulfur? I'm going to start with the sulfur. It was +6 over there, +6 over there, +6 over there. Has there been a change in oxidation number? No way. Not for sulfur. What about for hydrogen? +1 over here, +1 over here. No change. And I'm running out of options. -2, -2. No change. So this is not a redox reaction. Make very sure that you've got that right. Okay, next one. We haven't finished the question because it said where there's a redox reaction taking place, identify the reducing agent. Okay, so let's get this clear. I'm going to just erase that. We know that this is not a redox reaction. So we're going to cross that one off. It's not redox. But what we're asked to do now is to identify the reducing agent present. So guys, what does the reducing agent do? Come, AB.
It donates.
Reducing agent is rad, donates. Reducing agent donates. So guys, that means that if I take something like sulfur and look at it in the first equation, plus oxygen, and it goes to SO2. Look what's happened to the sulfur. It went from 0 to +4. Now, what sort of change has that been? Is that a gain of electrons or is it a loss of electrons? It has gone more positive. Guys, you've got to get this. It's gone more positive, so it has lost electrons. It has donated them. So this sulfur undergoes what process? A loss of electrons? What do we remember? What is a loss of electrons? Come, what was the word? Oil rig. Oxidation is a loss of electrons. So this is oxidation. And it's a loss of electrons, guys. That means it is the sulfur that is the reducing agent because it has donated. Loss of electrons, the reducing agent always undergoes oxidation. Okay, let's look at the next one. And what you can see in the next one, the reaction B, we start with sulfur dioxide plus oxygen, and it goes to sulfur trioxide. Now notice what's happening here. It starts at +4 and it goes to +6. If it becomes more positive, loss of electrons. Loss of electrons means oxidation. There we go. Means oxidation. Therefore, the sulfur of the sulfur dioxide is the reducing agent. Notice what I said? Sulfur of sulfur dioxide is the reducing agent. Guys, I hope you got this. We've just done 2 questions, but I hope it consolidates things. We need to go to a break. After the break, we'll be back for some more.
Guys, during this break, you do have the challenge question. We want to see your answers, so make sure that you get on them and also get on Curio, vote for your favorite teacher for the Get Connected competition, and also take the test yourself for our own K53 test. I'm sure that you're going to enjoy it, but during this break, I'm sure that you'll be watching the 3.10, so make sure you watch it and tell me after the break, did you learn anything at 2 or 3? Let me know. See you after this. Welcome back, guys. I'm sorry about the 3.10. You're gonna see it after at the end of the show. It's so rare that I even forgot. But you saw the minister tracking there, guys. It's very important. Great tips. Even if you're still doing grade 11, those tips do apply to you guys. We all use the same study methods, and it starts now for you. I mean, you're left with few months now before you become a real matriculant.
Hey, absolutely. In some schools, the new leaders are even in place.
Yes.
And congratulations to those of you that are taking on that role. Maybe you're the head of the SRC or the what do they call RCL?
Mm-hmm.
Go for it, guys. Put everything into it. All good learning experience. Okay, can I get on?
Yes, John.
I had a little problem with my board, so I hope it's not going to play around too much.
Can I take a bet, John, about this competition?
Okay, tell us a little bit more just
guys,
so that I can get this sorted
simple
out.
steps for the Safeways K53 learners and drivers manual competition. It's simple steps. All you need to do, 1, you buy the book or the app, you download the app, and then 2, you go on our Facebook page, if you have bought the book, of course. You enter, there is a link there with your details, your personal details. You put in your details there, and you must keep your receipt. Remember, if you've bought the book, keep the receipts. And then the third thing that you need to do is to like the Learn Extra page. I believe you guys have liked it, and also like the Safeways K53 page, and that's it.
Okay, so AB, if I just go and like the page, because I like to like the Learn Extra page, I'm always liking. Am I going to enter the competition?
If you have liked the page, it's fine. All you need to
will I have entered the competition?
No.
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 I've got to get the app or the book
Yes.
because there's a mechanism that links those two together.
Yes.
Okay, so you've got to make sure you've bought the book or got the app. You can't just like the page for liking the page. Okay.
And you can't just enter as well thinking that, because when we draw you, we're going to want the receipt of the book or the receipt that you got for when you're downloading the app.
And it's a big prize, so we're going to check that. Guys, there are rules to this competition. Make sure you follow the rules. Okay, so let's get to the challenge question. I want to get this out of the way, done and dusted. I gave you the first example as a redox reaction. The burning of petrol, so petrol, like something like octane, which we could write as C8, H18, burns in oxygen to form carbon dioxide and water. Now this isn't balanced, not saying it was balanced, but have a quick look here and have a look at the oxidation numbers. 0 over there and what we have over here, -2 and -2 over there. So clearly it is a redox reaction. Over here, +4. And over here, if we were to look at the reaction, what we'd recognize is that is +1, and there are 18 of them. And here we're getting something strange, but clearly there's been a change in the oxidation number. So what we're going to need to do is to say there must have been -18 over here. And if that was -18 divided by 8, -18 over 8 gives you the oxidation number there. It can be, doesn't have to be a whole number. It's worked out like that over there in that case. And you can see which one has it gone from. This one is large negative, okay? Large negative, and it's become +4. What is it going from? A large negative number to +4. It has donated. Remember, we are donating electrons. Electrons are negatively charged. So this one would clearly be the reducing agent. So the carbon of octane would be the reducing agent. That's the reducing agent. And the oxidizing agent is oxygen. This is the oxidizing agent. It has had to take electrons. It's gone from 0 to -2. And if it's gone from 0 to -2, it has gained electrons. It's become more negative. It's undergone reduction. It is the oxidizing agent. Okay, that was one thing that happens in a car. Now, AB,
Yes, John.
another reaction. What are the learners saying? Another reaction in a car. Anybody got an idea?
Let me tell you what they say.
Come.
Tell you.
Okay, we need to move on.
Okay. Okay. Petrol, also petrol.
Yeah, petrol, we've done that. And it's the carbon in the petrol that is undergoing, what was it? Oxidation. It is the reducing agent.
So
Next one.
It's fuel cell, the one that you spoke about.
Oh, the fuel cell. Guys, very good one. Hydrogen fuel cell. Brilliant idea. It's in hybrid cars. Yes, they will undergo redox reactions. Okay, we're not going to go into that one as a detail. Is there another one?
Direct methanol fuel cell.
Okay, methanol, same sort of principle as here, fuel cell. Guys, I want to deal with one more. And perhaps this is because I grew up in Durban. What do we know about cars? They're made up of mostly iron. And when they react in the presence of water and salt, then they undergo a rusting process. And it's, even if you've got very good paint, it's not pretty to get rust. Something that we have to guard against. And here is a perfect redox reaction. Look what happens. Iron goes to iron 3. Let me show you what the oxidation number is there. This one is -2 times 3 is -6. +6 divided by 2 is +3. So iron has gone from 0 to +3. It has lost electrons. That means that iron is the reducing agent. It has undergone oxidation. What's happened to the oxygen? Well, look here. Oxygen has gone from 0 to -2. It gained electrons. It underwent reduction. If it underwent reduction, we say it was reduced. It is the oxidizing agent. Why is it the oxidizing agent? Because it has made oxidation happen to the other reactant. It has made the iron undergo oxidation. Okay, need you to understand that link between the reducing agent and the oxidizing agent. You only have two reactants. If you identify the thing that has undergone oxidation, it is undergoing oxidation and making reduction happen to the other reactant. Let's do one more example. We're going to go back in our notes unless there are questions. Are there any questions? Okay, you look for the questions.
Yes.
I've got a few minutes to do this one. Okay, so very quickly, I'm doing question number 4, and maybe we'll get to do question 3 as well, because it won't take very long. Chlorine is added to solution of potassium iodide. So we've got chlorine plus potassium iodide. Now, you should realize that what's going to happen is we're going to get potassium chloride, 2 of those, and we're going to get iodine being produced. Now, if that's the case, this is a reactant, that's the reactant. What's the oxidation number there? 0. The oxidation number there, -1, because it's a chloride. That's +1. This one's 0. So I hope you can see that's not too difficult to assign the oxidation numbers. Now we've got to keep track of what's happened. We went from 0 to -1. What did we do? That means that is a gain of electrons. Okay? Why? Because it's become more negative, guys. This is the oxidizing agent. It underwent reduction itself, but it took electrons. Remember, oxidizing agent gains electrons and means it takes electrons. What about the iodide? Look what happened to the iodide. It went from -1 to 0. That means it lost electrons, or it donated electrons. If it lost electrons, that means it's undergoing oxidation. If it's undergoing oxidation, this is the reducing agent. Now, give the half reactions for what's happening. Let's do those half reactions very quickly. Half reactions just splits them apart, and we're going to say it's Cl2, it gained electrons. Let me quickly do it so we can put it in. It gained 2 electrons to form 2 Cl-. And that was my reduction reaction. Doesn't matter which way I do it, which order I do it. What about the other one? The other one was iodide, 2 iodide. It went to I2 plus 2 electrons, and there we've got the oxidation. Now, if we add those two together, as it asks for the net reaction, we're going to see the 2 cancels out with the 2. We're going to go Cl2 plus 2I- gives us 2Cl- plus I2, and AB, I'm out. Thank you so much for joining us. Over to you.
Thank you so much, John. It's been great. Just a quick question. I know we're out of time. Is photosynthesis a redox reaction or oxidation reaction?
It depends on what's happening. It can be a redox reaction and it might not be.
All right, cool. Thank you so much, my sisters, for tuning in. Really appreciate it. Remember to check all the competitions and the details that we have for you on our Facebook page, facebook.com/LearnExtra. For now, check out the 3.10, and we'll see you some other time. Peace.